Hello guys and gals, welcome to another segment of mail time, and this one is a very exciting mail time to me. At least I think it is. I'll let you be the judge. What I have here is a camera that was sent in from a local, and they run an apartment complex, and these are the cameras that they use. Now the guy that does the camera work out there seems to think that I may be able to use this on my Microscope. It is a security cam as fast as a Samsung SCC-B1311. They're off over there. But as you can see, the video output is a B&C jack, and it runs on 12 volts DC or 24 volts AC, and it has a few controls on it and switches, and some switches here to set different video ranges. Also has a mount that can go on the top or the bottom, and it also has this direct drive lens 2.8-12 mm f1.4. Excuse me. Now guys, I don't know nothing when it comes to cameras. I don't know nothing about cameras. I just have to go online and search and see what I can find. But he tells me that he thinks I can use this on the video microscope. Now the direct drive, you know, unplugs from the body of the camera, and it screws off, and you can see inside, you can see the die for the lens, and this is some type of metric thread, but it looks like all this can come off also and be changed out. I'm just not sure. And the lens, it says, has F and N, and when you move this back and forth, you can see the center goes in and out, and telephoto and wide, and you see when this is moved back and forth, the outer lens goes on. Well, anyway, this is motorized, but he said I wouldn't need the lens. What I would need to do is several things. This is the top off the Microscope microscope, and this little aluminum piece will screw out. There it goes. And the inside of this is threaded. So what I need to do is two things. Figure out a way to adapt this to this, and then figure out a way to convert this output to something that can connect to the computer. Again guys, I know nothing about cameras. If any of y'all have any suggestions or pros and cons about trying to do this, I would love to hear it in your comments down below. And our next item is what I am really excited about. Now, let me go ahead and give you the story on this. I get up, I think it was Sunday morning, and I noticed I had a text message on my phone from one of our good friends, and there was also a video posted, and it was Mike from Mike's Radio Repair, and the text message got my interest up real good, so I had to go and watch the video. So I went and watched the video, and I'll leave a link down below, and if you haven't seen this video, I would suggest to go watch it yourself. So if you want a spoiler before watching the rest of this video, look down, click the show more tab. You'll find a link to another video if you want to go watch that before you see the unboxing of this. If you don't want to, then we'll get on into the unboxing. Now, one thing I can tell you about Mike that a lot of people can learn from him. Now, I don't know who does it or if he does it, but when he ships a piece of equipment, He does a wonderful job at packaging it, and I can already tell you from the last few items I got from him, it's just unbelievable how well things are packed. So let's go ahead and rip the top off and let's see what we got in here. And as you can see, foam on the top. And it's not thin foam neither, it's thick. One piece, two pieces, three pieces. Alright, let's get on in here and see what's all in here. Again, as you can see just how well things is packed. Foam is cut, stuff in it. Now Mike, it's a little bit of story behind this. You would have to watch the video of Mike's to really get the full understanding. And if you could see the text messages and stuff, that would really blow your mind. But this piece was purchased from Mike. It's in this box. But as always, every time Mike sends something, he always throws some goodies in there. So we're going to look at the goodies first before we get down to the meat and taters. Okay, first items. There's a end-mill to B&C connector. Can never have enough of these. This is a DC to 4 gigahertz, and I think it's some type of dummy load or an attenuator, bi-directional, high operating surface temperature, caution, max input watts 25 watts, it's 20 dB at 25 watt. And I think that's end-mill connectors on this. Yes, sure is. Mike, I just don't understand. He has so much stuff. And here's a 50 ohm fixed attenuator, 20 dB. And it's also end-mill. Very nice stuff. Good quality stuff. Alright, next package. Set of cat rated multimeter probes. Cat 1000, 1000 volts DC with alligator clips. I guess these are a screw off. Yep. I recently picked up some from China, and I don't see no branding on these. No idea what the branding is, but they remind me a lot of my 01 scope probes, made about the same way. And good feeling leads, not stiff but not too flexible. Protected connectors. I really like them. Now I still have a pair of these cheap China made probes, and I ain't even took these out yet, because I picked up like 3 pair of them. I've just been using them on low voltage circuits, but I've noticed that, you know, nothing fits that I try to slip on. Nothing fits the tips of them, and the connectors are deformed. It's shaped almost like a D. It's hard to plug in the meters. In fact, that was already cracked. Brand new, you know, crap. And we have another probe. This time it's a B&C connector. Real nice made lead. Very flexible. Silicone. And this is wonderful. These are HCK. And I can barely read that. You know, my eyes is not as good as it used to be. But it looks like, let me grab a mag light here. .200 volt, 3 amp tweezers. Now this is perfect for getting in there and especially service mount work. I've had a set of probes that I filed down just for doing that, but this will be so nice just to get right down there on a little component and test it. Very nice. Okay, next item. We're gonna unwrap, and I'm seeing it's a meter. Alright, what we have here, BK toolkit 2704B, 1000 volts DC, 750 volts AC max. We got a 10 amp, unfused, 200 milliamp maxed for amperage, and measures hertz. The voltage range, microamps, transistor tester, our diode single, and up to 20 megahertz or 20 meg on the resistance test, and goes from 20 to 2000 on the capacitor range. Very interesting. Oh, no batteries in it. Okay, got some batteries in it. Let's see if it powers up. Let's see, probes. That's what he sent a set of probes for. So we got on diode test. And this responds pretty quick. I don't know if y'all can see this or not. But I've never had a meter to do this. I've seen one that did this. When you short the probes together, you get a little symbol up there. You zoom in on it. Neat. And we'll just test the diode. Right. I know some of you back here that already knows what's in the bottom of the box is screaming right now, get on with it, get on with it. We'll get to it in just a second. You know, anything that's sent in, you know, I appreciate it, and I just love it. It has the AC/DC switch. I'll have to do a teardown on this meter and just see, you know, what it's all about, but we'll do that in another video. Okay, I can already tell what this is without even getting into it. And what we got here is a Barker and Williamson B&W, for those that remember them. They used to make also watt meter dummy loads. I had one of those that I used on the bench for many years, and it finally had blowed the diode in it, so I had to take it apart. That was a job. You got to drain the oil out and sweat the back off, and actually put 2 feed-throughs through the back of it and move the diode to the outside, so we never wouldn't have to do that again. But this is a 75 ohm low pass filter, and it was made by Barker and Williams Incorporated, radio manufacturing engineers up in Darby, Pennsylvania, USA, right up there close by where Mike is at. This is model 426, and can't read the serial number, but these was good for running on the back of your transmitters to filter out unwanted singles, especially, you know, if you messing up your neighbor's television with your ham radio or CB radio or whatever, you know, you would get these, and that would take the filter the noise out. I actually got one that I've been meaning to tear down, but without having the correct piece of equipment to check it with. This is old Bell Industries, J.W. Miller division. Someone sent this in to me about a year ago, and it's holds up to 1,000 watts, 30 megahertz, 2,000 watts PEP single sideband. Attenuator greater than 80 dB above 41 megahertz. 50 ohm input and output. You know, and I always needed to test it to see if it's any good, but I need to tear it apart, clean it up, and you know, I got a spectrum analyzer on the IFR, but I just didn't have a tracking generator, so it's hard to test stuff like this without a good tracking generator. Now Dino sent in a noise board that I used and checked a few filters that I had, and was able to make it out pretty good. You know, didn't get real accurate results, but close enough to get them somewhere in line. So as you can see, the top of our box is empty, and when I watched this video that Mike sent, I had to have this unit, and I'll go ahead and tell you that, you know, at the moment I didn't quite have the funds to go ahead and get it, and Mike donated some of the shipping on this to me, so that really helped a lot. And another viewer contacted me, and he also watched the video, and he wanted to send in a donation of it, and his wonderful wife matched his donation. So luckily I got this at a bargain to start with, and then even after more of a bargain. And I know y'all seen Dino comment on some of the videos, and he was the one that made the first donation on it. So, you know, a great big thank you to Dino, Kilo Lima Zero Sierra, and his wife, Kilo Lima Zero Sierra Sierra. Matching call signs, I love that. So big thank you to you guys. Y'all really came through on this and helped quite a bit. So let me go ahead and get this out of the box. And I'll let you watch this just to see just how much foam Mike puts in these boxes. He really really knows how to pack stuff. Like I say, I don't know if he's doing it or if he's paying somebody to do it, but I know one thing, if I had something to ship, I wish he was here to box it up and ship it out for me, because he really does a great job on it. We'll get down to it in a moment. Boy, it's buried in there. Starting to see the handle. Alright, I think we're down. So, what was in the bottom of the box? We have a B&K Precision Model 2620 Spectrum Analyzer with built-in tracking generator. And Mike was kind enough to make a nice copy of the manual and sent that in with it. Now, you know, I've been wanting one of these for a long time. I think the option now to put tracking generator in my 1200 was around $1,500, what I was told, and that won't going to happen. One thing, I need to spend $250 on it right to start with to get the terminator pad replaced. Now, someone suggested some 50 ohm terminator pads on the internet. Well, it looks about like that, but it will not work with the IFR 1200. The the resistor terminator pad is actually two resistors in one. It's a 40 ohm and a 10 ohm put together, and the power handling is around 150 watts. So about 250 bucks for that little thing. But this takes care of needing to get a tracking generator for the IFR, and for the deal that I got this at, you know, I couldn't beat this. So we'll power it up. Now, Mike did tell me that I need to go in and clean some of these switches and get them taken care of. So I'll have to do that. I won't do it in this video. Got a lot going on tonight, so I just wanted to get out here and show you that Christmas comes twice in September. So yeah, we'll take a look at it. Okay, so what I've done, I've hooked up this Bell Industries filter, and it's supposed to pass anything below 30 megahertz. Now, I'm going to tell you, most of them that I've seen would pass right on up to about 40 megahertz or so, or even a little more. But anything below that, it should pass, and it should null out any of the higher frequencies. So we'll turn the tracking generator on, and I'll bring in center frequency about 43 megahertz. You can see it's passing, and then does a complete dip out to the bottom, so it's filtering out anything above about 43 megahertz, which isn't, you know, bad for this this filter. Well, I got the Barker Williams filter up there, and as we can see, it's dropping off just about 54 megahertz. If I put this on center frequency. So yeah, so we're passing up to about 54 megahertz, then we'll drop. Now, if you're running the CB with this could be a problem. You know, and I'm sure I don't have everything set up right. You know, I got no terminations, and I need to get down and read the manual. I'm just doing this from what I can remember from years back when I used to use a standalone spectrum analyzer and tracking generator. So yeah, I got to get myself educated a little bit more on this. But yeah, but you know, the main thing I wanted this for was to look at tuning our UHF duplexers we built. So let's have a look at those. So I got two of the duplexer cans sitting here. Now I'm taking consideration as that I don't have the pre-cut cables yet that we need to properly do this. And the proper way of doing it is use all four cans. And what you would do on the other two cans is, you know, you go from antenna port to the tracking output, and then from the receiver or transmitter into the input, and you would terminate the open cable. And without using a termination, we're going to probably see some artifacts on our screen that we normally wouldn't see if everything is on it. But this will give me an idea if these cans are even resonating at 440 megahertz. Okay, if you see that the spectrum analyzer is still at 54 megahertz, so we'll roll the frequency on up. And that's center frequency. So it looks like center frequency on the notch is around 543 megahertz. Now what does that mean? That means that we got to go inside the can and change the length of this center rod so we can play with getting this here tuned down a little bit more. And I think the rod's going to have to be extended some to get that on it. So we're about 100 megahertz shy of where we need to be. Now, you know, just roughing out something out of the coffee cans like we did, you know, we could be anywhere between 300 and 500 megahertz until you go in and fine tune them. Another thing we're going to have to do is look at our pickup. Probably going to have to increase the length of the pickup rods, and that would also bring it down in frequency. But without running the terminations and the coax that we need to be running, I was telling you about the artifacts, and you see how the artifact is here. So we actually got two humps, and we'll have to get that nailed down and get this brought out. And then I'm not even going to try to tune the notch. As you see, we do get quite a bit of tuning range out of the notch. But right now we're so far off of frequency that we've got to get that that tuned out. And this should be able to put the cans what it needs to be. Now where we need to be is around 444 megahertz or 440 megahertz. And you can see we're passing our 440 megahertz. You can see on the screen we're passing that quite a bit from center gradical on the scale. And like I say, I've got to read up more on this tracking generator. I ain't even had time to go through the manual. This is, you're seeing it as I'm seeing it. So yeah, we got to do a lot of reading up, and I got to make a bunch of cables and get some attenuators, because you know I might want to be looking at the spectrum analyzer on the transmitter, and we just can't feed a a radio directly into this. Now the IFR 1200 right there in the back, you know, it'll do on-air testing. So I'll punch in, I got a CB on the bench, 27.205 megahertz, key to radio, you know, and read directly on air. And this, you can't actually do that with it. In fact, if you put an antenna on here, this thing's going to pick up so much stuff. You know, oscillators and equipment running, power line noise, all kinds of stuff. And I'll just demonstrate that just to show you. So what do we have here? This is a Motorola precision selector cavity, and it's for VHF. Now back when I ran the 147.375 repeater here in Greenville, I had a split antenna system with no duplexer, and a 100 watt PA would desense the receiver. So what this does, this is basically a passband cavity, and you can see just how crusty it is. All the paint's flicking off of it. The copper's still in good shape, and this is copper. It's not plated, it's solid copper. You can look all in there and see it's copper. Even the plunger's copper. Now the rod is steel that runs up there, and some of the bolts are steel. But this thing is old. I haven't ran this piece of equipment since, I don't know, somewhere in the early 90s. So let's take a look at it now. The way we tuned this thing back then was using a receiver with a sinad meter on it, and we tuned it to pass a frequency from a handheld without using any spectrum analyzers or service monitors or anything. So it hasn't been changed since then, and it was set for 147.375. So let's look at the spectrum analyzer. I've already got the cables connected, and let's see what it looks like. Okay, we'll use our center gradical for center frequency, and I'll roll this up to 147.3. And even as old as it is, as long, you can see she is so close to being on frequency that it's not even funny. Too far. And that's dead on frequency right there, 147.3. So what happens is, as you can see, you know, it's going to pass 147.3, and it's going to reject mostly everything else that comes through up to a certain level, you know, of attenuation in it. And I would have to pull the specs. I've got them somewhere around here, somewhere in the book, so to see how much insertion loss and just how much, you know, that this thing will null the other frequencies. Again, this is where I need to get more into knowing a little bit more about this piece of equipment to better understand everything, to get some calculated measurements out of it. But I just thought I'd show you that, you know. Okay, I killed the light so you can get a better look on the screen. But as we roll through the frequencies, you can see all the spikes that's coming up through here, with everything in the shop. And way down here at this end of the band, you can see a lot of spikes are popping up and down. So, you know, a lot of noise, and that's why you can't usually put any, you know, to use this as a on-air type of spectrum analyzer. So, you know, a big humongous thank you to Mike for stepping up on this and putting this out there for me to be able to get. And, you know, Mike, I just can't tell you how much that means to me. Great deal on it. Nice piece of equipment. I'm gonna go ahead and open it up probably tomorrow, clean out all these switches and get them working like they're supposed to be, where it'll get rid of that noise. Actually, you know, I was going through it a while ago, I saw very little noise on it, so maybe by playing around with it like you were doing, you clean most of them. And another big thank you to Dino and his wife for the contributions. And, you know, I just want to thank everybody for supporting the channel the way that they have. And you know, it just means a lot to me, and, you know, we really thank you. So now, you know, another thing, we're doing our FT101 series, and we'll even be using this on the FT101 to check our filters. You know, we got single sideband filters, we got CW filters, we got an AM filter that we'll be checking, and this will be perfect for checking those out. And while I was already into it, this past weekend I did get a chance out of taking time to work on some other people's stuff, was start building the extender cards that I needed. And, you know, this is something that you don't have to have for the 101 series, but, you know, me, I work on a lot of this stuff, you know, by, like I tell you in one of the other videos about sorting the wires through the board and plugging it in, gives you point to access. But when you got, you know, a dozen of these things come in every couple of months, extender cards, you know, work out pretty good. And these are just old school made. It's just a piece of single-sided copper clad. You got to make sure you get the right thickness, you know. You don't want to get nothing no thicker than what the original boards are. And all I did was just took the socket, you know, figured out where I needed it, notched it out, that way the socket was plugged in it, covered the thing with tape, using an X-Acto knife to peel back the tape, put our resist ink on, and throwed it in the etching solution. And then, you know, took it out and cleaned it up and sorted the connector on. I did leave 2 copper pads at the top, where I'm going to take some brass screws and file them down and solder it to it, let it come through, and put a nut on either side of the connector. And this will give just a strain relief on the connector without, you know, being a strain on the circuit traces. So yeah, these will come out real good. 2 more of them to make. I'll probably get that done by the weekend. A lot going on here, and just got a Cobra 2000 that someone sent in to do a recap job to it, and got that finished up. And I've got several more ham radios to go through. Got the TS-120 out this past weekend. No problems on that. And had a couple more VHF rigs in. Got them out. So it's always busy here in the shop. So big thank you to everybody. Thanks again to Mike, Dino, and his wife. And thanks for the extra goodies, Mike, that you sent in. I do have to look at getting some attenuator pads. I have an old one that came with my ComServe laboratory service monitor years ago. And this is it's 20 to 40 dB maximum, 25 watt to 100 watt attenuator. So I can use this, but this thing is old. I need to get it checked out and make sure it's still functional like it's supposed to be. But anyway, I'd like to hear your comments down below. I'll leave a link to the video that Mike did on this so you can have a look at that. And might be very interesting too if you haven't seen it yet. So big thanks to everybody, and again, Christmas for the second time in September. We'll catch you in the next video. Thank you.